suppose Japan has some occurrence, and my weight sensors sense that occurrence, but did not sense our Bangladesh occurrence. So why this happening? I don't know. I checked several times. This sensor can capture the suppose others countries occurrence, but our occurrence cannot capture.
Oh yeah.
I suppose it's a internet problem. Some possibilities. So your data is not correctly sent to this server. Maybe
I don't know.
this internet connection is slow, so the signal did not go through. I'm not sure, but every signal is sent to the main server through internet. So quick data transfer is maybe required.
But our wait internet speed is very high. I don't know why.
Okay.
So sorry to interrupt this lively discussion. We are actually going to start our next technical session. So this technical session, which is technical session 6, severe weather, and this was supposed to chair by Air Vice Marshal retired Professor Dr. Ajit Tyagi, and also session will be co-chaired by Professor Dr. Nasrin Akhtar Madam. But I think due to some difficulties, Ajit Tyagi sir, we are waiting for him. He probably would join, but for the time being, Professor Dr. Nasrin Akhtar Madam will chair the session, and Dr. Fatima Akhtar Madam, she's an assistant professor of Department of Meteorology, University of Dhaka, will co-chair the session. And there is, we have 6 presentations at this session. And there is another thing to mention to both the chair and co-chair is the paper titled ICMCS 031, simulation of thunderstorms over northeastern part of Bangladesh and its thermodynamic features using WRF model. The presenting author has some power difficulties today at his residence. So he has actually asked to shift his presentation. So this will be the last presentation. That means the presentation starting from 15:10 to 15:30 Bangladesh time will be the time slot. So there's just a slight change into the schedule as well. So over to you both Nasrin Madam and also Fatima Madam to conduct the session. Thank you.
Okay, thank you very much. So already Mr. Shubho already announced that the presentation will be up to 13 or 14 minutes. Then please, Dr. Fatima, please remind after 13 or 14 minutes. Then we can, should I start? Okay, then I request first presenter. This is ICMCS 029 microsecond and sub-microsecond fluctuation in geomagnetic field due to lightning. It will present Wing Commander Professor P. Kumar. He is from MIT World Peace University, Pune, in India.
Thank you very much, Professor Akhtar. I'm really pleased to present you my presentation here. This is with respect to my, let me put it on the screen first. Can you make it a full screen now? Hello?
No.
Can
Fatima?
you make it a full screen now?
Fatima, full is, he demands for full screen.
Yeah, yes. Yes. Is it there's no screen now?
Yes, it's okay.
Is okay? Okay.
It's
Thank you
okay.
very much for giving me opportunity. Thank you, Chair. Microsecond and sub-microsecond fluctuations.
Would you please make it presentation mode? Would you please click the presentation mode?
Can you please continue with presentation mode? This is the lower right corner. It is the presentation mode.
So your slide is moving. Please try it first.
Slide is okay.
Yes,
Slide
the
is coming on
second slide. Yes, would you please second slide? Can you show us second slide also?
It's okay.
Is there any difficulties? Oh no.
No. No, for my side is okay.
Please send your slide. We will.
No, it will be difficult for him.
Is it okay now?
Can you please do in a presentation mode? It is the normal PowerPoint PPT. Can you please display as a presenter mode? Okay, Fatima, it's okay. I think it's okay. Okay, please continue.
Should I continue? Okay, fine.
It's okay.
Okay, thank you very much. Let me go to first slide first. Now, this is the title of my presentation of microsecond and sub-microsecond fluctuations in geomagnetic field due to lightning. Now, many of you will be curious that why geomagnetic field coming in the atmospheric process. It does actually. Significance of the study is that we have high frequency magnetic field fluctuations within the corona regime in the atmosphere. Lightning have got connotations on magnetohydrodynamic expressions and in the atmospheric flow. These magnetohydrodynamic expressions are caused because of the charge fluid. If the charge fluid is there, then you have got another force coming to play, and that force is known as Lorentz Force in the plasma domain as an important body force which cannot be disdained. Now, it is its repercussion on buoyancy and convergence has to be examined and cannot be obviously there isn't. So I will touch upon this topic, and after that, in the end, I'll say that what is the implication of this in our meteorology.
Sir, your slide is not moving. Please close the slide first, then share your slide, then yeah.
Now should I put a full screen?
Yes, sir. First, close the slide and open the slide first, then press the slide mode. I think there is a problem. You press it first, slide mode first, then open it. So it is not.
Okay.
It is the internet problem?
No. First share your screen, full screen, then open your slide.
I think Dr. Prabhat Kumar, I may help you. If you are not in the presentation mode, if you just open the PowerPoint slide, just open the file first, not the presentation mode. Just open the file and then share your screen and then start presentation in the bottom right corner.
I'll open the file now.
Yes, that will work. Earlier time, I think you have started the presentation mode and then shared your screen. That's why it was only showing the first slide, because the file was showing only the first slide.
Okay, now this thing. I've got a slide on the screen now. Can you see now?
No.
No, don't start your presentation now. You just open the file at first and then
Okay.
share your screen and then start the slideshow, not before.
Have you got now?
No.
I've got the screen now.
No. It's not coming. Yes, now.
Is it
Now
there
started to share. Yes, yes. It's coming.
now? Is it okay now?
Yes, it's okay. Now you start the slide. Yes,
Yes,
this
yes.
button.
You're getting a screen now? My slide is there on the screen. Is it moving now?
No, not moving.
We are still in the previous viewing, just seeing the first slide and just showing the file as it is. Maybe you could do one thing if everyone agrees. You could leave the slide presentation and just show us the slides all together one by one. In the current view, if the both chair and co-chair agrees,
Yes.
maybe we could continue from like this, just not in the presentation mode, just as a file mode.
Yes.
So Dr. Kumar, you just leave the presentation.
Okay. Fine.
And just to go back to your previous settings.
Okay. Fine.
क्या कहते हैं? शिखा. Sorry, as there is a problem for Professor P. Kumar to present the paper, so we can continue for the next presenter, and in the meantime he could manage the presentation, or is it okay? So I'm calling the next presenter. ICMCS 030, numerical analysis of storm surges by Vola cyclone in 1970. Presenter is Nadio Kono. He is from Meteorological Research Institute, Japan, Meteorological Agency, Tsukuba, Japan. Please present Professor Kono.
Thank you, Madam Chair. Okay, I will try to share my presentation. Now I changed to presentation mode. Is it okay?
Is it okay? Is it?
Okay, then I will start my presentation. So I'm Nadao Kono, Meteorological Research Institute of JMA, and I and my colleague at BMD, common with Hassan, and I at Arif Hussein in this presentation. And I am really happy to have a chance to make presentation in this conference. And the content is like that. So start with introduction and calculation setting is explained. And I show you result and end with conclusion. First of all, start with introduction. First of all, as you know, Bangladesh suffered from storm surges for long years. And this is one a paper which describes the historical record of storm surges. And according to this table, so Bangladesh suffers many storm surges. And actually, I have to get the. So the left table indicates that the maximum storm surge, although it's not, I don't think it exactly show the storm surge, but I think some of the storm type. So we cannot simply compare these values, but as you know, in Bangladesh coast, quite large storm surge occurred in history. And moreover, this is the fatality record. And as you know, Bangladesh really suffered from storm surges. Storm surges killed so many Bangladesh people. And as ranks top one, the storm surge in 1917 is listed, which was generated by the cyclone, but the cyclone is often referred to as Bora cyclone. Bora is not a cyclone name, but hereafter I just say Bora cyclone. Anyway, this is really historically deadly cyclone. Moreover, this damage is often read as the worst damage by meteorological, worst damage of meteorological disasters. So therefore, it is quite historical case. And moreover, last year was the 50th anniversary year of that cycle. And I saw several articles which described about this cyclone, but mostly about the disastrous situation. And of course, those articles explained how Bangladesh decreased the fatalities with improvement of forecasting system and operation and so on. However, there was no detailed explanation on storm surge itself. That is why I would like to try to conduct hindcast of this case. As I mentioned, Bora cyclone in 1970 was a really deadly cyclone. And however, there are several, this was a cyclone condition. I referred from several references. The maximum wind could be quite large. However, according to several references, the minimum central pressure is only 960 hectopascal. I really doubt it. And anyway, according to category of the cyclone, IMD put this severe cyclonic, I don't remember the exact acronym, but anyway, it's second intense class. And this is Stephenson hurricane wind scale. Sorry, it was ranked to 4 or 3. Anyway, and storm surge is often said that about 3 to 10 meters, perhaps typically 6 meters, I think. And the damage is quite huge. The economic loss is like this. and this total is 300,000 to 500,000. Quite a large number of people were killed by this cyclone. And basically, most of those killed people are directly killed by storm surge itself. And therefore, I check as the cyclone intensity. However, there are several opinions. At first, I checked IBTrux data, and data set 84 shows these record. According to this analysis, the wind speed is only up to 64 knots, which is much weaker than the possible wind speed. And as for lower pressures, as I mentioned, mostly describe that the minimum pressure is around 900 to 950 to 70 or so. As I checked the tropical cyclone intensity scale of IMD, and as I mentioned, the Bola cyclone was classified to second strongest cyclone, this one. And actually, this range, it's around 100 knots, which is quite different from this analysis. And I pick up several differences, and which range to 81 to 170. And anyway, it is considered that the cyclone actually, the cyclone wind is around 100 knots, not 60 or so. This is one example of Emmanuel 2005. This is the solid line indicate the simulated wind, which is in MPH, and I converted to knots. And this is quite strong, and the maximum wind is over 120 knots. But anyway, there are several discrepancies among the listed cyclone intensity. As for storm surges, basically the main source could be the Frank and Hussein 1972, which indicate the storm surge height, detailed storm surge height in the coast of the Bangladesh. Actually, in that time, East Pakistan. But anyway, it's okay. And at first glance, the value ranged to 2 or 3 to 12.4, which is quite large number. But actually, this is the unit is feet. So roughly, we divided by 3, which means the maximum storm surge height is around 4 meters. 4 meters sounds a little bit low. And I check the description in detail. And according to this paper, these values actually indicate storm surges. And observed high tide levels were subtracted from observed maximum water level. So therefore, those values indicate some amount of storm surge, but the value itself themselves are not so in real. And as for storm tide and storm surges, there are also various references from 4 meters and to 10 meters. And anyway, it seems that what storm's tide could be 6 meter, around 6 meter at most. This is the possible storm surge generated by bolus cyclone, I think. So now I explain the how to conduct simulation of this storm surge. So this is the outline of storm surge models. Actually, this storm surge is originally developed at MRI of GMA, and this model is also provided to BMD, and the BMD use this model as in operation. And actually, storm surge is not so complicated. It's vertically integrated two-dimensional model. And the region is actually, this case, I choose two regions. The outer region is shown, it's upper right, this region with 1 minute resolution. The physical distance is about 1.7 kilometers, 2 kilometers. And as for inner region, the area becomes small, and the resolution is 30 seconds, about 1 kilometer. And there are several options, but anyway, the forecast time is 48 hours, 2-day calculation. And as for TC forcing, so we have several options, but this time, so I use Meyer's formula. The model also support calculation with NWP input, but this time, so I didn't use. The reason will be explained later. And as for astronomical tide is included dynamically, the put in the boundary at outer region. And then astronomical tide is input in the inner region. And the base of astronomical tide, so I calculated from global ocean tide model phase 2014. It's one of the common global tide model. And it actually considered quite many tidal constituents like this. And I checked this performance at the South Pacific and found that the predicted tide value is quite accurate with observed values. So therefore, I just apply the predicted astronomical tide at boundaries. As for reference, this is one example of astronomical tide in the Bay of Bengal, like this. So as you can see, the tidal motion occurs, and also large tidal motion happens in the estuary part of Meghna River. And as for the bathymetry data, so the base data is GEBCO 0830 seconds. There are several latest versions, but actually our target is 1970s, very long ago. And perhaps the detailed bathymetry condition must have been changed, but we cannot use those old bathymetric data. So therefore, I just use this data. And this is the reason why I set the finest grid resolution at 30 seconds, because fine mesh detailed condition is not alike without bathymetry in those days. So therefore, the main target is to simulate general behavior of storm surges. And as for TC pressure profile, I use Meyer's profile, and the drag coefficient I set like this as constant. The way of calculation is shown like this. First, we calculate astronomical tide without any meteorological forcing. Then storm surge calculate with simulated storm astronomical tide. Then and Bora cyclone hit the coast of Bangladesh in 12 November, but the calculation start from 00 UTC on 9 November once spin up. And we focus the 40-hour calculation at 12 UTC on 10th November. So first of all, before, so I explained that the storm surge model can support the enthalpy input, and I actually check the ERA 5. However, the cyclone intensity of ERA 5 is very weak. So as you can see, the minimum pressure is around 1,000 hectopascal, and maximum wind speed is 60 knots. Actually, it's quite similar to the IB trucks data, but I don't think it's reasonable. So therefore, I do not try to conduct storm surge with this enthalpy ERA 5 input. As a matter of fact, I have just tried with ERA 5, and it turned out the simulated storm surge is only 2 to 3 meters at most. So it's quite lower than the often referred values. So therefore, based on many reference, main reference was actually the Emmanuel 2005, and I determined the possible cyclone intensity like this. And this is the blue line indicates the Vmax, and this green line indicates central pressure. And perhaps this maximum wind speed is around 120 or so at most, which could be reasonable. And this is actually calculated winds at Chittagong, and this is the maximum value is 80 knots. And according to the historical report, Chittagong observed 78 knots, and after that it was broken. So perhaps the simulated wind speed could be reasonable. I just comment out, so in the early stage, wind speed is quite low, but it is because the cyclone is out of model domain. This is actually the maximum wind and minimum pressure in model domain. So they actually, those values do not indicate the cyclone, the condition of cyclone field. So we have only to focus on this part. And now I show you the result. This is the simulated storm surges. The cyclone approach and move eastward, and generated quite large storm surge in this region. So, and this is the simulated maximum storm tide, which means water levels. And as you know, the maximum water levels is around 3 to 8 meters. and 8 meters in this inner 8 meter in this inner part. And also, since the cyclone move the north of coast west eastward, so almost four coast of Bangladesh felt this storm surge. It's quite a wide area. So storm surge occurred in almost all regions of the Bangladesh coast. It indicates. And this is the more detailed image of water level and astronomical tide, and also storm surge. Storm surges are the difference, anomaly from the astronomical tide. So as you can see, quite large storm surge happen, and maximum water level is around 6 meters to 6 meters around. And the cyclone move from west to east. In the first, in the eastern part, storm surge happens before the high tide time. And however, in the middle part, the storm surge happens exactly same time of high tide time. So that makes the maximum water level highest. However, in most some stations in some point in east, the storm surge happens slightly later than high tide time. However, the timing is still almost same as the middle point, not low tide. So, and large storm surge anyway generated. As for Chittagong, so it is often said that the deadly highest storm tide was generated by the coincidence of astronomical tide. But this simulation indicates that basically storm surge itself was large.
Sir, your time is almost over, and
okay. Okay, and this is the inundation map, but I skip this. And I rush to conclusion. So one point, as for the why deadly storm surge happens, the one main reason could be astronomical tide. Storm surge happened in the high tide time of spring tide. And this is the annual tide variation. And as you see, in this time, the storm astronomical tidal motion is quite large, which means it's spring tide. And storm surge happened in the high tide. That makes the maximum water level highest. So this is the conclusion, but perhaps I can skip to read. Thank you.
Thank you very much. Thank you very much for your valuable presentation about Bola cyclone. It is actually very severe cyclone. Now, any question from audience? You can raise hand for the question. Okay. Okay, then I want to ask one question. You did a very nice job as Bola cyclone was happened in 1917. It was very long years ago. So similar cyclone was the cyclone Sidor. It was when it is landed over Bangladesh. At that time, it is also very high intensity, almost 2 or 3 category 2 or 3. Then did you correlate that Sidor cyclone with that 50 years back cyclone, Ola?
Thank you. So as a as a matter of fact, we have already conducted recent major cyclones, including Sidor and the latest Amphan.
Amphan, yes, yes, and
yeah.
funny also, yes.
Yes, and such hindcast was actually conducted with among BMD2.
Okay.
So for getting used to using storm surge model, and we have already simulated those cases, but polar cyclone was not tried because the cyclone intensity was uncertain.
Yeah,
So
yes.
that is why I tried this time.
Oh, okay, that is the importance of the studies. Okay, thank you very much. Any questions?
Stop sharing your screen.
Sorry, Fatima?
Sir, yes, okay. Sharing consensus screen.
Thank you.
Please,
Thank you.
okay.
I hear clearly. Oh.
Okay. Then it is okay to Professor Kumar. Okay.
Sir, unmute first. Kumar sir, please unmute your.
Professor Kumar, please unmute.
Yes, yes, done it.
Okay.
Is it okay now?
Yes.
Hello, can I speak now?
Yes.
I want this thing on the screen. I'm not getting it.
You cannot see. Screen is here.
Okay. May I speak now?
Please continue.
Okay. The topic of presentation is microsecond and sub-microsecond fluctuations in geomagnetic field due to lightning. The next slide. It is significance of the study is high frequency magnetic field fluctuations within corona regime of atmospheric lightning have high connotations on a magnetohydrodynamics expressions of atmospheric flow regime. This is the importance, and that's why I'm going to take up this topic. Lorentz force in the plasma domain cannot be disdained if the flow is considered in Navier-Stokes equations. Its repercussion in buoyancy and convergence may also be further examined if we are doing everything in the plasma domain. Next slide. Now, prelude to thunderstorm lightning, I'll just update here before I start my main presentation. Hydrometeor collisions in the presence of supercooled liquid water droplets produce lightning that is known to us. A 1 second interval conventional data in the present geophysical lab are not able to resolve high frequency fluctuations of magnetic field in microseconds or sub-microseconds. May it be negative CG lightning, positive CG lightning, that is cloud to ground lightning, and intra-cloud lightning. 90 to 95% cloud to ground lightning, CG lightnings, are negative lightnings, and they have got very low ampere current, 30 kiloamperes only. 5 to 10% are positive CG lightning. They are 300 kiloampere currents, very high. And intra-cloud lightning are further low in current-wise. They are 1 to 30 kiloamperes, and but they have got almost same duration as a cloud to ground lightning. Electrical records reveal that the late stages of intercloud discharge are very similar to those dose of cloud to ground discharge during a period of between successive return strokes. That is junction stroke process. There is J current, and during the period after the last return stroke, there is the final process, F process, is known as. They are just updates from lightning literatures. Corona, we define corona as a envelope around lightning arc about 120 meters diameters in clear air around the vertical negative CG lightning, where the positive ions, induced positive ions due to cascade of negative ions coming down to the ground, will be streamer, and they will radially propagate upward, sideways. Electrical conductivity of 1 meter radial distance is about 10 microsiemens per meter, and between 10 to 50 meters distance is about 1 microsiemens per meter. Next slide. Now, something about the magnetic field also we must know, because we are handling magnetic field only in this presentation. The magnetic field at any point has got a hump at the interval of about 50 microseconds from the lightning point. Immediately at any point, 1 kilometer or 2 kilometers, the hump comes and then it dies down. So that is the peculiarity of magnetic field, and this must be accounted when we are solving the Navier-Stokes equation along with the Lorentz Force. So next slide. Electric vis-a-vis magnetic field fluctuations due to lightning. This is the conceptual model, and we must account for this once we are solving the equations of mathematical equations of Navier-Stokes equation. The figure shows the microsecond scale electric pulse in CG lightning. Time scale in the x-axis is 25 microseconds per division, shows fluctuations of electric field on microscale time axis in cloud to ground, CG, and intra-cloud lightning. DU on the vertical scale shows the digital units. So this is adopted from Rakov 1996 paper. The wave generated by the lightning burst in electric field at closer distance induces corresponding variability in associated induced magnetic field. This I put in red because this is the magnetic field fluctuations we are concerned with. During intra-cloud and cloud to ground, that the IC and CG lightning flashes, and simultaneous fluctuations are expected in total magnetic field too. Next slide. Conclusions of induced magnetic field here. Induced magnetic field, I refer to only magnetic field which is generated spontaneously because of lightning cascade. That is, the electrons are moving, so induced magnetic field is generated around it. So conclusion for induced magnetic field is intra-cloud positive and CG negative or positive lightning all exhibit microsecond waveform. That is first. Second one is the angular frequency omega of corresponding magnetic field fluctuations value could be as high as of the order of 10 to the power 7, though average omega will be 10 to the power 3 to 10 to the power 4. This is taken from Raisha 2011 paper. Third important observation is the lightning current J is summation of its oscillatory current, which can be mathematically parameterized as J0 cos omega t, and rudimentary continuing current. And continuing current is something which is already existing in the background during the return stroke also. That is JB. So J0 is much more than JB. So we can sum up these and make an equation for the lightning current J. So then correspondingly, we can have also magnetic field equation B. Magnetic field is represented by B, which is B0 cos omega B subscript B. So this is subscript B is actually refers to the continuing current. Corresponding to continuing current, we have got B, and corresponding to fluctuations, we've got B0 cos omega t. Next slide, please. Conclusions for geomagnetic field. Now, if you have got a lightning stroke, negative lightning stroke, then as per the Faraday law, we can say that if your thumb is going up, then your fingers, curling fingers, will show the direction of magnetic field. So here, the center point is having a lightning stroke from a negative lightning stroke, and the circles are showing your magnetic field. And the straight lines are here, geomagnetic field. So these magnetic fields, azimuthal magnetic field we call it, which are induced by the lightning current, are overlaid over the geomagnetic field. So we can see that the center line AC, the induced magnetic field circles are opposite the geomagnetic fields. And this AC will have very high degree of fluctuation. So I read here, assuming negative CG lightning landing at point A, then current J is vertically out of the plane of the paper. An induced circular magnetic field will be clockwise. It will be laid over the in situ horizontal geomagnetic field, GM, in straight lines. The equation, therefore, will be B is equal to B0 cos omega t plus BG. The BG is obviously summation of BB plus geomagnetic field. Would be more pronounced over the AC line. AC line you can see. And this line is the one which is having more pronounced analysis from Lorentz Force point of view. And if you solve the equation, we have to confine our equations limitation in this region, that is about 50 meters approximately from the lightning point. Conclusion number 2, geomagnetic field is, whenever the two magnetic fields interfere within the entire circular region, in situ geomagnetic fields will experience some micron and microseconds fluctuations at corresponding levels within cloud as well as below the cloud till ground level due to IC, that is IC obviously is within the cloud and CG is from cloud to ground, so up to ground level. This is very important point because this will have repercussion in application of meteorology. I'll discuss in the end. Now, third is conclusion about the geomagnetic field is angular frequency omega of the corresponding geomagnetic field fluctuations value could be as high as of the order of 10 to the power 7, though average omega could be 10 to the power 3 to 10 to the power 5. This slide I have put here, B is equal to B0 cos omega t plus BG in the red, because this is the equation which is going to be most important from the point of view of mathematicians who will solve the Navier equation along with the geomagnetic fields. Now, there are the applications. Many of you will be interested in the applications instead of mathematics. Now, if you solve the next slide is applications. If you solve Navier-Stokes equation with the body force of Lorentz force, and Lorentz force mathematically I put here the summation of Lorentz force can be put in two parts. One is the first part in the left, in the right side is the magnetic pressure, which is always acting downward like hydrostatic pressure. And another last term is the convergence term, which is horizontal term. Ex is the unit vector in the horizontal. So, and this term is comprised of two parts, the B0 by 2 omega, 2 mu, and del B0 by del x. So this del B0 by del x corresponds to variation of magnetic field in horizontal. The higher the variation, the more is the powerful this term. The third term in the last expression is e to the power minus 2z by delta. Now this term is having a minus 2z. That means if the z is negative, this will grow, and z is positive, this will fall. So this will fall very fast, exponential. Now this term plays the entire role here in the formation of tornadoes. Just see the first picture of tornado shown here is this small tail coming down. This is obviously assuming that only intra-cloud lightning is there, and there's a this expression, the del B0 by del X is very strong expression, and gradually it's coming down because if exponent Z is negative, then this will grow. It's growing here, and second slide also is growing, and just see, this is forming tornado. Now, third slide, I have taken the situation when cloud to ground lightning is also there associated along with the intra-cloud lightning. When the cloud to ground lightning is also there, then there's a tornado building up from ground and upward. So this is also happening, and so many times it is observed that the tornado is coming down as well as is going up from ground to up. But because exponentially decreasing term in the end, this upward going tornado diffuses very fast, which is seen in the picture. This I've taken the actual conditions. So that's why this is diffusing. You see, most of the tornadoes observed, they diffuse very fast. Now, you may ask question, if they're coming down, how the cloud also comes down. Cloud comes down because the coming down tails, they are having strong winds, and that winds, because the Bernoulli's pressure down, brings the pressure down, and the condensation level also comes down along with that. That's why you can see observed tail. Okay, that is what the entire presentation is, and that is a connotation with the meteorology. That's all.
Okay. Okay, thank you very much for delivering a nice presentation and providing us very important message about geomagnetic fluctuation. Any question or suggestion? Our session chair is already with us. Any question? Okay, sir, I want to ask a simple, very simple question because it is very difficult to understand the presentation because it is not my field. Here you use the horizontal component of induced magnetic field. What about the vertical component of the magnetic field? Is it cancel out each other or something?
That has no role to play mathematically. Dynamically, it has no role to play. Horizontal component has got role to play in dynamics of the Navier-Stokes equation. So vertical component has role to play in giving the vertical magnetic pressure, which was the first term. The last slide was showing two terms, first term and second term. If you show the last slide, I can point out.
B naught sine omega t, this has no impact actually.
No, I can get it. Come again, please.
You show that B is equal to B naught cos omega t, then
yes.
Then sine omega t has no impact.
No, it has got merged with the first term. You're seeing the first term? The first term here.
Yes.
This first term has got a role to play actually because the first term is a vertical pressure term.
Oh, vertical pressure term.
This is magnetic pressure term. This pushes the tail downward.
No.
Okay. And second term.
Yes.
Second term is comprised of three terms. First term is a constant. Second term is the variation. And third term is exponential decay term. These decays are exponentially upward, but actually it extends exponentially downward. That's why you see tails all over.
Okay, thank you. And another very small question. as there is a geomagnetic field fluctuation, very small fluctuation, is there any impact our daily life, or it is a long-term effect?
I think it will not be a long-term effect in any case. It will be a short-term effect only with respect to
what type of effect we will we feel it? What type of effect here we expect?
I don't foresee any long-term effect in the fluctuations. The fluctuations on a very, very small scale, micro scale fluctuation. So no geophysical labs, they account the fluctuation only 1 second. I have proposed actually it should be recorded microseconds too, because it is how repercussions in the meteorology. So now they have taken up actually Mumbai laboratories, they have taken up observations on these lines. But microsecond fluctuations on human life, I have not understood that so far.
Thank you very much. So I would like to take over the session. I would like to Ajit sir to take over the session. Ajit sir.
Am I audible now?
Yes.
Yeah, thank you. And I'm sorry for joining late because of the time. I think a difference between Bangladesh, and I somehow missed the earlier part of the presentations. So I'm really apologize. At the outset, let me compliment Dhaka universities and congratulate for completing 50 years. And thank Professor.
100 years, 50 years for our independence.
Yes, and 100 years, yes, 50 years and 100 years of the university. Great, two great, I think, celebrations being coincided with this particular event. So congratulations. And thank you for inviting me. And I am really sorry for having missed the joining it a little late. The presentation of Dr. Kumar, as always, is really a new concept which is trying to bring out and relate it to the tornadoes. Its impact in the genesis of tornadoes, we'll have a better understanding. How much is going to be useful for forecasting is to be seen, whether we can use such computations if these are available and they've got some forecasting value. So with this, we have now, I think, some rescheduling of presentations, I believe. So with that, the presentation number 4 is to be done now. Am I correct? Hello?
The presenter 4 is already here. So we can
ask. So Dr. Azam, please go ahead with your presentation. It is on study of characteristics of lightning, flash, and associated hydrometeors. Let me also tell you that this session on extreme weather covers wide-ranging topics. Lightning, of course, is there, then the thunderstorms, cyclone, and also the heat waves followed by the methane. So all aspects related to the severe weather are being covered in this session. So we have now presentation on the lightning, flash, associated hydrometeors by Dr. Azam. And so,
thank you, sir. Am I audible?
Yes, please.
Can you see my screen?
Yeah, please go ahead.
Thank you. Honorable Chair and Co-Chair, respectable distinguished, good afternoon. I am A.T.M. Shofil Azam. The topic of my presentation is study on characteristics of lightning flash and associated hydrometeors. Professor M. Rafiuddin, Professor Dr. M. Rafiuddin, Professor Dr. Nasrin Akhtar, and Dr. Ashraf Dewan are co-author of this research. This research is funded by Banbase. Introduction. You know, lightning is a sudden high voltage discharge of electricity and it's a natural phenomena. Due to time constraint, I should skip these slides, and these are introduction. These are basic things about lightning. I skipped this. This is the background of this study. You know, Bangladesh is frequently impacted by various natural hazards, including lightning. Bangladesh experiences severe thunderstorm and lightning flashes, especially in pre-monsoon season. The effect of thunderstorm, including lightning in our country, are not insignificant. Recently, the fatalities and injuries in Bangladesh due to lightning has been increased devastatingly. The annual short from 1990 to 2015, the annual average lightning fatalities was 114, but from 2010 to 2015, they found the annual average fatalities increases and it is 251 per year. Following the death of 81 people on 12 and 13 May 2016, Bangladesh government has declared lightning as a natural disaster. Some research about lightning fatalities, injuries, and financial losses and lightning occurrence time have been done about the Bangladesh. Although there are many research about the mechanism of lightning all over the world, including India, unfortunately, in Bangladesh has very few research in this context. In order to manage and minimize the risk associated with lightning in Bangladesh, understanding the characteristics of lightning occurrence is of great importance. This research examines the influence of different hydrometeors on lightning activity over Bangladesh. So the objective of this study to simulate severe thunderstorm associated with lightning using WRF model, to analyze the different hydrometeors associated with thunderstorms, to observe the vertical profile of different hydrometeors, to analyze the spatial distribution of hydrometeors, to find the relation between lightning activity and hydrometeors. Case selection. Figure A shows the fatalities due to lightning over Bangladesh on 12 May 2016, and Figure B shows the fatalities on 13 May 2016. It is found that northwestern part of Bangladesh experiences more fatalities on 12 May, and mid to southern part of Bangladesh experiences more lightning fatalities on 13 May. In this context, we intended to simulate these two cases to examine to find out the relation different hydrometeors with lightning activity. So our simulation time is 48 hours. These data are used for initial and boundary condition. GLD 360 network biseller data, lightning observed data are used in this research, and BMD 3-hourly observed rainfall data is used. This is the model domain and suitable parameterization. The grid resolution is 3 by 3 kilometer and simulation period 48 hours. Sensitivity tests to the microphysics option were performed for WSM6 class scheme, Ferrier scheme, and Morrison double moment scheme, and found that WSM6 class scheme is appropriate for this present study. The output attained at 15 minutes interval. This is the model simulated reflectivity for 15 minutes interval of 48 hours. By analyzing this reflectivity and lightning fatalities area on 12 and 13 May, which I already shown you, we selected these 2 times for our case study. First one is 16:30 UTC of 12 May 2016, and second one is 13:30 UTC on 13 May 2016. And for detailed study of hydrometeors, we select this region for case 1, and we select this region for case 2. Model validation. Figure A shows the spatial distribution of BMD observed rainfall for 6 hours from 15 to 21 UTC of 12 May. And figure B shows the spatial distribution of model simulated rainfall. In this slide, figure A shows the spatial distribution of 6-hour rainfall observed by BMD, and figure B shows the model simulated rainfall for same duration on 13 May 2016. Here we also found some spatial and temporal distortion, but overall we can say the model simulation very moderately matched with observation. Results and discussion. Figure A shows the variation of wind at 850 millibar region with the spatial distribution of maximum reflectivity, and figure B shows the same things at 400 millibar region. It is found that moisture is supplied by southwesterly low-level wind, which produce convection, and the northwesterly strong wind is dominated in the mid to upper level. This combination produce turbulence in this region. Here we have choose 400 millibar region because we found in this region the temperature was -16 to -17 degrees Celsius, and which is the favorable region for charge separation into the thunderstorm. And figure C also shows the maximum, the relative humidity. And it is found that the relative humidity rises about 100% at the center of our case of thunderstorm. In the northwestern part of the country, the intense relative humidity is found as like as maximum reflectivity and fatalities due to lightning. This slide shows the same things for case 2, as I explained in my previous slide. And we found almost similar result for case 2. And here we found the temperature at 400 millibar level, -15 to -16 degrees Celsius. This is the vertical cross section of thunderstorm for case 1. This slide shows the vertical cross section of thunderstorm at 9 different time of 60 minutes interval. Figure A shows the vertical cross section of thunderstorm at the beginning stage, and figure B shows the vertical cross section 1 hour later from the beginning, and then C, D, and E. Figure E here, figure E shows the mature stage, vertical cross section at mature stage, and it's time 16:30 UTC, which we have selected as the time for case 1 in my previous slide. And figure I shows the vertical cross-section as decay stage. In this way, I can say the A to E shows the beginning to mature stage of thunderstorm, and F to I is the mature to decay stage of thunderstorm. And this thunderstorm lasts for about 8 hours. It is found that the intense core of the reflectivity reaches up to 55 dBz, which indicates strong convection, and the system top reaches about 250 millibar, which indicates the presence of a large amount of hydrometeors. This slide shows the vertical cross-section of thunderstorm through the maximum reflectivity. All these cross-section are taken through the maximum reflectivity position. And this is for case 2. And here we found almost similar result for case 1. But this thunderstorm is last for about 14 hours. For this reason, we take here the interval between two vertical cross section is 90 minutes. And here figure A to E shows the initial to mature stage, and figure F to I shows the mature to decay stage. This slide shows the vertical profile of hydrometeors for case 1. Figure A shows the vertical profile of maximum reflectivity, B for grapple, C for Q ice, D for snow or Q snow, E for rain, F for cloud, and G for wind. Here, purple color indicates the beginning stage of thunderstorm, and this sequence is from beginning to mature. Here, black line indicates the mature state, and then mature to decay. Here, red line indicates the decay stage of thunderstorm. It is found that grapple, ice, and snow retain on the higher altitude, and rain and cloud retain in the lower altitude. And vertical wind profile shows the low level downdraft and mid to upper level updraft. And it is found that for all these cases except ice, the maximum value of this parameter are found at mature state for black line, 1630 UTC. The vertical, the cloud water lifted up by updraft and cloud ice particle grow by the expense of liquid water at the mid to higher level through vapor deposition and freezing. The formation of snow and grapple takes place by conversion of cloud ice and by the collision between ice particles and cloud droplets. This process also gives feedback to vertical velocity by a latent heat release. This slide shows the same things for case 2 on 13 May 2016. And we found almost similar result for all these hydrometeors. Here also we found for all these cases except snow and cloud and rain, the maximum value of these hydrometeors or parameters almost in the mature stage. Figure shows the characteristics of grapple for case 1, and figure B shows the characteristics of grapple for case 2. Figure C shows the characteristics of vertical cross-section of grapple for, snow for case 1, and figure D shows the vertical cross-section or characteristics of snow for case 2. And figure E shows the characteristics of ice for case 1, and F shows the characteristics of ice for case 2. It is found that the grapple extended from below 0 degrees Celsius to above -40 degrees Celsius for case 1, and for case 2 it reaches above -60 degrees Celsius. And for snow, we found it extended up to above -40 degrees Celsius for case 1, and above -60 degrees Celsius for case 2. And for ice, we found it extended from below -10 degrees Celsius to -50 degrees Celsius for case 1, and for case 2, it extended up to -70 degrees Celsius. We found the maximum value of grapple for case 1 about 2.5 gram per kg and 4 gram per kg for case 2, and for case 1 it was 2.5 gram per kg. For snow, we found for case 1 it was about 1.5 gram per kg, and for case 2 it was about 3 gram per kg. And for ice, we found for both the cases the maximum value was 0.18 gram per kg. Here, beside the lower level downdraft and upper level updraft, we observe the random directed wind into the hydrometeors. The coexistence of supercooled liquid droplets and ice snow grapple indicate the possibility of stronger reaming process. This condition is favorable to enhance the lightning activity during occurrence of thunderstorm. Chaudhary et al. Also found the similar condition in their study over Northeast India.
Shofil, 4 minutes left. Please limit your presentation.
Okay. Yes, thank you. In this slide, figure A shows the special distribution of vertically integrated grapple for case 1 and B for case 2. Figure C and D shows the vertically integrated snow for case 1 and case 2 respectively. Figure E and F shows the vertically integrated ice for case 1, and figure F shows the vertically integrated ice, special distribution of vertically integrated ice for case 2. And we found all these hydrometeors in our selected region of case 1 and case 2. Here figure A shows the total lightning flash on 12 May 2016 collected from GLD Vaisala, and figure B shows the model simulated flash density for case 1, and that is for on 12 May 2016. And here figure C shows the total flash collected from GLD Vaisala for 13 May 2016. And figure D showed the model simulated flash for 13 May. And we found the observed lightning flash and simulated lightning flash in our selected case region. Now the summary and conclusions. These points are actually the summary of this presentation, which I already discussed with you in my previous slides. And the main conclusion of this research is it is found that the coexistence of supercooled liquid droplets and ice snow grapple with downdraft and updraft inside the storm indicate the possibility of strong dimming process. These conditions are favorable to enhance the lightning activity during occurrence of thunderstorm. So thank you. That's all. Thank you. I finished my presentation.
Thank you very much. Any question? Ajit sir, unmute.
Okay. Thank you, Dr. A very exhaustive presentation covering the hydrometeor relationship with the lightning using the WRF model for the help of two case studies of 12th and 13th. If there are questions from the audience, they are welcome. Otherwise, we can have questions from panelists.
Yes, sir, I have a question.
Any question answered?
Yes, I have a question.
Please.
Go ahead. Thank you, Mr. Azam. This is a nice presentation. I have a question. In your slide, you showed that the data of Vaisala for the validation purpose, the lightning flash data from Vaisala, you showed that in your slide.
Yes.
Can you tell me that how can you get this data from Vaisala? Is it paid or is it free, or we can get this data?
Oh, it is paid, and it is paid data. It is not free.
Okay. So thank you.
Thank you.
So, any question? So I have one suggestion actually to Shoful. You showed that there is some wind distribution. Please, your work is in the cloud scale. So if you display the wind as not whole wind, it is the relative wind, storm relative wind, that would be more effective. Okay. Then please do storm relative wind.
Yes, thank you, ma'am.
Okay, based on these two case studies, are you able to come out with some threshold values which can be used forecasting, say, 40 hours in advance, 48 hours in advance about the areas and the timing of the lightning?
No, sir, I didn't find the threshold below, but it is a continuous research. I will try to find out the threshold value in next time.
Yeah, because some of the national Met agencies are using now WRF model to provide advisories for the thunderstorm lightning warnings. So you could try this along with the BMD. Okay, thank you.
Okay, thank you, sir. Thank you.
Dr. Nasreen, you could ask for the next presentations to next presenter to make presentation.
Okay, thank you. So next presenter is Dr. Abdul Mannan. He will present an analytical study on heat wave in Bangladesh.
So am I audible to you?
Yes.
Yeah, thank you, Honorable Chair, Co-Chair, and my colleagues and others. Welcome to my presentation. Actually, you might be knowing that there are so many hazards are visiting in Bangladesh in every season. But this year it was quite different. After a few years later, this year we have faced a long periodic heat wave condition, which suffers a lot. Though there are the pandemic period was there, but during that period we have to.
Dr. Monat, we did not see your screen yet now.
Yes, I have shared your screen. Stop sharing. I just share, but I don't know. Maybe I have to.
Please close and again.
Yeah. There are problem. Once we start the presentation, the problem arises. It's not stopping also. Interesting.
Yes, it's coming.
Our screen is not seen.
Yeah. That is the problem. That is the.
স্যার তাহলে আমি দেই আগে আপনি ঠিক করেন যদি পারমিট করে।
Okay, you can.
Okay, if you have problem, then we can ask for the next or third number.
Okay, I am ready. On favor of Abdul Ilyas Akhtar, I want to present now. Is it okay, Appa?
This is okay. It's okay. Then now our next presenter is Dr. K. Mullik. He will present simulation of thunderstorms over northeastern part of Bangladesh and its thermodynamic features using WRF model.
Am I audible and my screen is visible?
No screen yet now.
Screen is visible or not?
No. This is the same problem like Dr. Mannan.
Now, is it visible?
Screen is coming, but not in presenter mode. PPT is not open.
Is open, share,
Okay.
open the PowerPoint slide, then share.
I did that, but what happened actually?
Then we can go for the last.
You should share full screen mode, not any window or PPT. Full screen mode.
Okay, I am trying.
Then we can go for the last one. Presenter is Tahrim Jannat. Oh no, it's coming. This one.
Is it okay, Appa?
It's okay. Okay.
My screen is seen.
Yes.
Yeah, please go ahead. Please go ahead.
Okay, thank you very much, respected.
No, please do the presenter mode.
I did it in the presenter mode here.
But not coming. Maybe it is the same problem as Professor Kumar.
Is it okay or not?
No, not okay. So we can proceed for the last presenter, Tahrim Jannat. In the meantime, so I would like to invite Tahrim Jannat Moushumi for her presentation. Title is Study of Atmospheric Methane over South Asia, Analysis of In situ Data and Satellite Measurement. Tahrim Jannat.
Yes, thank you, Fatima Madam. Is it okay? Is it visible? Hello.
Yes. Please present.
Okay, thank you. Honorable Chair, Co-Chair, respected all other members, good afternoon. My name is Tahrim Jannat Moushumi. I'm second grade master student from Environmental Science Department at Nara Women's University. First of all, I'd like to thank the convener, Professor Dr. Tawhida Rashid ma'am, for arranging this international conference for all of us. My presentation title is Study of Atmospheric Methane over South Asia, Analysis of In situ Data and the Satellite Measurements. Firstly, I would like to apprise about the background of this methane and why we should care about the methane and what is my research purpose. What is methane? It is the second most important anthropogenic greenhouse gas after carbon dioxide and one of the most important short-lived climate forces. The lifetime is about only 10 years. And according to the IPCC 2021, the total anthropogenic radiative forcing is 3 watt per meter square, where methane directly contribute 0.97 watt per meter square, which is really very high comparatively to another well-mixed greenhouse gas. And now I am going to give small description about the sources of methane. Methane sources are very complicated to identify, and scientists divide the sources of methane into two categories. One is natural sources and another is anthropogenic sources. And from literature review, approximately 70% of global methane emissions are anthropogenic. Now, why I choose the South Asia region? Because the amount of methane emission in South Asia is really very high relative to another surrounding regions, and about 8% of global methane emissions are originated from South Asia, which covers only less than 1% of global land. And from this figure, we can see that this B, it is the Asia region is the column methane is really very high, and this figure is drawn from Geomagnetic satellite dataset by Frankenberg et al. In 2006. And the methane source result suggests that the Asian region is an emission hotspot of methane due to the large number of livestock, intense cultivation, biomass burning, and waste deposits. Now the data and tool. I'm using the weekly atmospheric flux sampling data and the satellite observation data, and for weekly flux sampling dataset to measure the greenhouse gas conducted at Kumilla weather station of Bangladesh Meteorological Department with the collaboration of Professor Dr. Kausar Ahmed in Dhaka University and the Japanese research team from AMASA project members in NIES since the summer of 2014. And this long-term record of methane in Kumilla has been already accumulated. And this is the first data set systematically in Bangladesh for greenhouse gas. And for satellite observation data, I choose the Tropomi dataset, which is onboard satellite 5 precursor, and that is launched in 2017, 13 October. And from shortwave infrared radiation, we can detect the methane from this satellite, and the availability of dataset from November 2018 to present, and the dataset is available for level 3 offline data. And for visualizing the Tropomi dataset, I am using the Google Earth engine, coding with JavaScript and Python. And this is the aim and objectives of my study. Aim is to understand the behavior of atmospheric methane over South Asia. And objectives are the analysis of temporal variation, methane concentration obtained in Kumilla, and visualization of Tropomi dataset using Google Earth engine. And then I did correlation between Kumilla in-situ data and Tropomi dataset. Now the results and discussions. I accumulated 2 years dataset from 2019 to 2020 from Tropomi observations, and have drawn monthly distribution of mean column methane. This slide is for monthly distribution of mean column methane in 2019 from January to June. And this slide is for 2019 July to December. And this is the next year for 2020 from January to June. And this slide is for July to December. And from this monthly distribution dataset, we can see that from January to May, it's almost same concentration of methane, above 1800 ppb, but it is relatively high in the October, November, and December, 1900 ppb. And then I just try to figure out the seasonal variation from this Tropomi dataset. Here is the A is for winter season, December 2018 to February 2019, and B is for summer season, March to May 2019, and monsoon season, June to August 2019, and D is for post-monsoon, September to November. And this one for the next year for seasonal variation. And from this seasonal variation, we can see the higher methane content in post-monsoon period, but expectation from the literature, it is expected that in monsoon period, methane concentration should be high. But here I can say that dataset are contaminated with thick clouds, so some dataset are missing in monsoon period. And I would like to just describe about the Bangladesh area, which is characterized by a very high percentage of rice cultivation area, about 70% of total country area. Therefore, methane emission from rice fields are very high. However, the highest content of methane was observed for the area of the capital city, Dhaka. And because of the limited availability of data for the third quarter of the year in 2019 and 2020, methane content for this period can be overcast condition, and the reason for very limited availability in monsoon period. And the highest methane content was observed in the third quarter of the year, especially in October. And for the end of the rice period called Aman, when most of the rice in Bangladesh is harvested. And in most of Bangladesh's area, the share of rice cultivation area is very high, and the expectation are two regions located next to the coast, the southwest part of where mangrove forests are located, and the southeast part with hill forest. In both of areas, methane content is lower in comparison of the methane content in other areas of Bangladesh. Now the results from Flux sampling dataset. This is the time series plot of methane in Kumilla, and weekly atmospheric flux sampling showed that surface methane in August to October, the higher value, and small peak in March. And then I did correlation between flux sampling and topomy data set, where the correlation is, if coefficient is 0.2, which is considered to be a negligible correlation, but here flux sampling data are taken almost to near the surface at 8 meters above ground level, and the topomy data set are the column abundance, and it is difficult to identify in which layer actually the methane concentration is available. From the vertical profile of column methane, we can say that the methane concentration can be found mainly at the upper troposphere. So methane from the surface area, the methane rises up with the prevailing wind and the mixing with another particle. So concentration is homogeneous in upper troposphere less than the surface area. Now the conclusions. The results obtained from satellite data proved a long-term increase and seasonal variability in methane content in the studied region, and the lowest methane content was observed at the beginning of the year, while the highest observed in the post-monsoon period, and limited availability of data for monsoon period June to August, which is characterized by cloud mass. And atmospheric transport of methane is difficult to evaluate and affects the spatial variability of methane content. So better knowledge of methane distribution and quantification of its emission flux is indispensable for assessing the possible mitigation strategies for methane concentration. So that's all for today, my presentation. Thank you all.
Okay, thank you very much. Any question? Okay, Tarim, you already said that the methane concentration is available in the upper level, almost maybe 300 hectopascal, maybe like this.
Yes.
How then how you say that the wind prevailing from the ground and go to outside, is it possible? Because our vertical wind is not that much strong to transport like surface to upper level.
Okay.
Because horizontal wind is transported, it is okay, but surface to vertical transportation, it is very difficult because it is a gravity. There is a gravity, so there is a balance. So vertical wind is very low compared to horizontal wind. So did you check these things?
It's give me 1 minute.
Madam, can I add something for this question?
Yes, of course.
Yeah, thank you. Thank you for the presenter as well as co-chair as well as chair also. The horizontal motion of atmosphere is there, but it has a good significant amount of wind in the vertical component is also there. Once we are talking about the wind speed, whatever it is, as horizontal component is very high, higher than the vertical one. That's why we are ignoring that one. Actually, in every cases, in every convection processes, there are it becomes very, very significant. Without significant vertical motion or air transportation, there will not be possible for formation of cloud or any other.
Yes, that I know.
During that process, some methane can be transported towards upward, and in the normal period also, as there are the that means though it is not so significant, but there is always
transportation is there, because in the vertical direction, the pressure gradient force is being acting, and pressure is higher in the lower and lower in the upper level. That's why there is the
Dr. Manan, I know that things
pressure gradient force, some amount of not only methane, any gas can be transported upward.
So yes, it is okay. Upward wind is there. Yeah, yes, I know, but just paddy field in the Kumilla and upper wind, vertical transportation from Kumilla to upper, it is very difficult to say. Or some.
No, it is there. It is there always. Even it can be Kumilla, not only Kumilla. Even it can be ocean place also. Once
no,
you
it
have
is
the
transported
vertical
from
component,
somewhere.
Everywhere there is the pressure gradient force from the surface to upward. So that their transportation is always
but
possible.
it is very low component. Okay.
The component is low. That's why methane concentration is also low.
Tarim, I have a suggestion. Please check others site, not only Kumilla, other site area that they can their concentration, and they may transport it to the Kumilla area. Why not? Or please check.
Yeah, I will do the high speed trajectory analysis for checking this issue, and I'm sorry, I told that upper troposphere, it will be lower troposphere.
It will be lower troposphere. Methane concentration is in the lower troposphere.
Yes.
Maybe no. Concentration is maybe 300 hectopascal or upper level. Please check.
Yeah.
Okay, I'll check again.
Tahrim, you had two data points. One is the surface observations, which are there at 8 meters or so, you were saying, and another is the integrated observation from the satellite. Do you have any idea of any vertical profile of the methane being monitored anywhere, or any paper which says how is the vertical distribution of the methane, which could throw some light about vertical motion and the layers in which the maximum amount of methane is present?
Yes, I have read a paper from Navin Chandra, which is for the India region, for the vertical profile of methane they did.
Okay. So that could throw some light that how it is transported upwards and in which layers it is the maximum, and how does it contribute to the total integrated methane column. Okay, thank you. We can move to the next presentation.
May I present now?
Dr. Mullik, you want to present now? Okay.
Yes.
Please present. Your slide is there.
Honorable Chair and co-chair, welcome to my presentation. I have different thunderstorms in the northeastern part of Bangladesh. Actually, the title is that. It is the joint project by Professor Abdullah and me, but favor of Professor Abdullah, I am presenting here. Next. So this is the, I have some motivation because the northeastern part is the thunderstorm occurring from in our Bangladesh. So I have to say something about that. Then objective of the presentation and the discussion conclusion. This is outline actually. Go next. So first simulate randomly select in the pre-monsoon season by using WF model with RW4. Then features related to the development of the thunderstorm.
আমি এটা নিয়ে একটু কনফিউশন বুঝছেন, এটার মেকানিজমটা অনেক টাফ লাগছে।
Excuse me, asked to mute yourself, please.
আপনি কি জ্ঞান শুরু করছে, আমি কোন রকম তাড়াতাড়ি করে শেষ করছি।
একটু মিউট। Okay. Then try to check 72 hours temperature simulation about the Bangladesh and then investigate the simulation effect to predict the with reasonable lead time. Next. Next. So this is the three-way nesting. So in here, I have presented the in-year core simulation results. Next. This is the WF model setup. Next. And, so I have used two data sets, global final data set and GFS data set into on the ground gates covering resolution. And other information is in build 30-second unit tested geographical survey data and 25 categories unit tested data. And GRASS is used to visualize GRASS, and Diana software is used to visualize the thunderstorm simulation results. Thank you. Next. This is the physics option. First, I have to configure the WF model. I have to do the sensitivity test to find out which a cumulus scheme is good for predicting the thunderstorms. Next. So I have did many schemes, 12 combinations I have run using FNL and GFS data set by visualizing mean sea level, temperature, to meter height, relative humidity, and theoretical area. Because this is the observed data, I have compared the result with the observed data so that I select these parameters. Next. Then I have tested the select region, the sensitivity test of cumulus physics option in terms of mean sea level, and I found that cumulus parameter 1 is good for selecting for predicting the thunderstorms. Next. And also I have did the sensitivity test in the Mymensingh region with the cumulus parameter and found that cumulus physics 2 in terms of root mean square error, it is best options. Next. Also, then I have again simulated all the cases and found that cumulus 1 parameter and GFS data source is best for predicting the thunderstorms. Next. Then I have finalized that cumulus 1 physics and GFS data set combination is good for for predicting the thunderstorms. But 5 out of 12 experiment is good, but the cumulus physics 1 and GFS data set is the best comparing the observed data of Bangladesh Meteorological Department. Next. And I have some basics references. Uzit Tegi sir, where is the SCR? I have reference his paper also. He did thresholds values for the thermodynamic parameters. So I have checked that thermodynamic parameters using ECMW global model run with the Diana software. Next. And we found that he mentioned, Uzit Tegi sir mentioned different thresholds of thermodynamic parameters, and it is seen in the left side. Next. And next, we know that this is the thermodynamic convective inhibition tape, etc. That's a theoretical background. Next. And we calculate, we have circle here because this is the region where sudden pressure drops occur, but thunderstorms occur in the northeastern part of Bangladesh. Next. So this is the Cape. This is theoretical value. We all know that. Next, and we simulate the convective available potential energy using ECMW model run, and we found that northeastern part convective available potential energy is very high. That is, it is the favorable condition for the formation of the thunderstorm over northeastern part of Bangladesh. Next. And also we set up the Diana software. Diana software means digital analysis and the WF model output, and also ECMWF model or other model output can be visualized by this Diana software in on screen editing facility. Next. Then we found the visualize the total index and total index some threshold values. Next, we found that in our regions it is greater than 46, which is almost consistent to the Uzit Tegi sir results actually. Next, and then I simulate the K index, which is next, which is also consistent to the threshold values. Next. And we found here it is 40. I make a question mark because I have case studies very few, so we cannot conclude this 46 more or less is appropriate for formation of the thunderstorm. It is not clear till today. Next. Another, we sometimes visualize the shelter index calculating with RS observation. Next, and this shelter index is visualized by Diana software. It is actually WF model output, and we found that it is less and minus 4 or less is favorable for the formation of the thunderstorm over northeastern part of Bangladesh as well as whole Bangladesh. Next, and we this is the Diana software setup. Next. And we calculate the lifted index and a special distribution of lifted index over northeastern part of Bangladesh, and we found if thunderstorm forms, then lifted index is -3 or less. It is a favorable condition, and we found in SMWF data as well as in the WF model output that this parameter is very prominent parameter for predicting thunderstorms over Bangladesh and adjoining area. Next, and we found that it is less than -3, and -3 is northeastern part of the country. Next. Next. And we calculate the DCI index, deep convective index. Actually, it is the measure of the low level temperature and convective instability, so that I visualize the Tegisar's DCI index threshold value. He mentioned 34, but we found next very near to the 34. So it is consistent to his observation actually when he did his research in the storm project. So this is the best scores in Bangladesh. K index, lift index, deep convective index, sweat index, and other scores should be mentioned. But I found in northeastern part of Bangladesh, lifted index and deep convective index is good for predicting the thunderstorms for 5 cases. Next. So Tegisar's thresholds values I remember again. Next. Now I have output analyze the mean cellular pressure that I found that in 11 UTC thunderstorm forms, but before that sudden pressure drops occurs in Dhaka and the adjoining area, but the vicinity of the low pressure thunderstorm drop in the right side of the pressure drop thunderstorms occurs. That is Mymensingh and Sylhet severe thunderstorms occur in April 2017. Next. And we time series of thunderstorm that we found that suddenly pressure drops. Next. And also we found in the wind pattern analysis, it is very difficult for me because the screen is very unseen and obsolete in my screen. Anyway, trap of low lies over Bangladesh, and it is West Bengal and Bihar, and it extends up to Sylhet and adjoining area. This is the favorable condition that means for the formation of the thunderstorm. Next. And also we found the relative humidity is maximum in the northeastern part of Bangladesh. And next. Vertical cross section, we found that the relative humidity extends up to 300 hectopascal level, and we found that distinct thunderstorms in a vertical column. That means it is a single cell thunderstorms. Next. And we found that Mymensingh and adjoining area at 11 UTC thunderstorms forms. Next. And then we analyzes the temperature. Mymensingh and adjoining area temperature falls suddenly due to deep convective rim, which will be seen later. Next. And we again found the time series of T maximum suddenly fall. Why fall? Deep convective cloud forms, and due to downpour of heavy rainfall associated with the thunderstorm, temperature suddenly falls. Next. And this is the Cape value which we found that it is Cape removal. When thunderstorm forms an 11 UTC, and then maximum convective available potentially reduces suddenly. So that before that 11 UTC, the Cape value was very maximum, but after the thunderstorms occurs, Cape value reduces its magnitude. Next. So we reflective factor simulated by the model also predict very well. It is greater than 50, which is found in the northeastern part of Bangladesh. So it is favorable for the formation of the thunderstorm. Next. So this is Lipton index. Again, we found that Sylhet and adjoining area, Mymensingh, we found that the value is -3 or less. So it is also favorable. Next. And we found that gusty wind is found Sylhet, Mymensingh, and adjoining area. So anywhere in Bangladesh, no gusty wind, but at the time of pressure fall, the vicinity of the pressure fall area, that is northeastern part of Bangladesh, experiences gusty winds. Next. And this is the time series of gusty wind. Next. So lower level vorticity also found positive, and its value is 30 or 30 into 10 to the 5 per second. It is maximum, so it is the favorable condition for formation of thunderstorms. And the model simulated very well using cumulation and GFS data. Next. So vertical wind shear we found maximum. It is also favorable for formation of the thunderstorm. In cyclone, vertical wind shear less, but in thunderstorm cases, vertical wind shear should be maximum, and the model simulate the maximum vertical wind shear. It is favorable. Next. So rainfall analysis, we found that now northeastern part, suddenly if you compare that 3 years before, no rainfall, but after 10 UTC, rainfall is starting and increasing. So it is the indication of deep convection. Next. So it is the comparison of model rainfall versus TRM data, but signature is same, but TRM has some biases, location and time biases. Next. Also model rainfall versus observed TRM, we found that there are some special distribution errors in TRM and model. Next. So this is there are many cases. So you have to go to next. I have 5 similar cases. You for the time constant you can go forward one by one. Same result we found, and it is validated by the observed BMD values as well as ECM model output, and also visualized by GRARS and Diana, which is very sophisticated visualization software. There are 5 cases analyzed, and we find that the ECMWF high resolution data and Cumulus 1 and GFS data is good enough to predict the thunderstorms over Sylhet, Mymensingh, and adjoining area. Though we have case analysis number is only 5. So if we compare that with the Ozi-Tegis search threshold value, it is consistent to the storm project results. So we can say in the conclusion that with the right combination of the cumulus physics of the WF model and analysis is the thermodynamic parameters like Schalter index, Lipton index, and also Cape values, and most prominent is convective, deep convective index, that is DCI. We can predict the thunderstorms over Bangladesh and adjoining area reasonably well. That is all today, sir. Thank you very much, sir.
Okay, thank you very much. Any question? Actually, we don't have time so much.
Dr. Malik, thank you so much for your very exhaustive evaluation of various thresholds and doing 5 case studies in great detail. My only submission is that please attribute this study of Tyagi to the young Tyagi, Bhishu Tyagi, who was a student at IIT Kharagpur. This study is not done by me, but but yes, I've been monitoring that work and it was a good quality work, and you have referred to a good paper, part of it. And I'm happy that threshold values are being applicable for the Northeast India and the Bangladesh as well. My only submission now is that we have now better quality data. GFS data of say 1 degree. Now I think data sets at 25.25 degree or even less is available.
Yes,
and
sir.
for mesoscale features, if we have got high resolution data, and if we can assimilate also radar and other data, then the simulations and the predictions and the forecasting will be much better. So in the future studies, please guide students to take up work with the high resolution data, and also try to assimilate satellite and radar data and other observations also in your analysis and the forecast. Thank you so much.
Thank you, sir. Thank you, sir. Actually, sir, I want to say something, sir. Sir, actually, please. By a STORM project, you did these massive works. Before that, I never found this type of experiment in subcontinent to find out the threshold value. So that sometimes you use your research work results as a threshold value, sir. Because Kolkata, Bihar, and Bangladesh like the same platform. And here, renowned Professor Dr. Nasrin Akhtar, he is doing good job in his university. We appreciate in this from him, and he is also a good researcher. And sir, we are always your blessings.
Okay, thank you.
Thank you.
Okay, the next presenter is Abdul Mannan, Dr. Abdul Mannan. Please present.
Is it visible, my slides?
Yes, now it's okay.
Yeah. So is it in presentation mode?
Yes.
Okay, thank you very much. Honorable Chair and Co-Chair and audience, welcome to my presentation. As I have started a little bit ahead of time, but in earlier times, but I could not completely make this presentation. So welcome you all. Actually, the title is Analytical Study of Heat Wave in Bangladesh. You might be knowing that there are lots of disasters are being affecting our Bangladesh territory. Out of this, heat wave is one of the crucial parameters. It has come after a period over in Bangladesh area, but even though it has good impact on the society. So in 2014, we have a severe heat wave condition over Bangladesh. Of course, it was there in West Bengal, Bihar, and other places surrounding to Bangladesh. But again, this year in 2021, we had to suffer a lot, and again, we have to face lots of problems. To make this event for the societal benefit with the forecasting process, actually, we have been working with the Bangladesh Red Crescent Society, and they have taken a mass initiative as per the forecast provided from Bangladesh Meteorological Department. And again, they have taken some sort of initiatives over Dhaka city area, considering the vulnerability and to reduce the risk associated with the heat waves. With this interest and with this challenge, my submission is to know how heat wave is behaving in our territory, when it comes and how long it prevails, and what are the processes, I want to say the meteorological processes are lying with that one, which we need to know. Otherwise, it will be very difficult for forecasting and providing early warnings. So, as already organizer have requested me to make this presentation in a short manner. So I will do accordingly. So my presentation contains introduction, definition, heat waves and cold waves in Bangladesh. I have to leave that one also, definition of heat wave. I don't want to say there. But you see, there are the 3 heat waves in 2014. That was with longer duration. Even in this year, after that, in 2014, we have a 4 consecutive heat wave situation that starts from March to May. Then again, I have to taken into consideration of heat wave situation with the process of prediction mode. Then I will go summarize. But of course, it will be a short because as organizer, as I told, they have requested me. So this is the existing definition of heat wave in Bangladesh. But even though I have to check with different recently published papers where it has been told that 95th percentile value will maybe the one of the threshold value for detecting the heat wave. I have checked that one, and I found that at some places the value is coming below than 36 degrees, that is 36.9 degrees in the case of Dhaka city area. And at other places, it is in the western places, it is slightly higher, but at other places, even slightly lower. So to make this event for better understanding, I actually used finally the definition which is being operationally used by Bangladesh Meteorological Department. So I have collected some data from BMD, that is station point data from long before, from 1962 onward. And I have tried to see the special variation of these heat wave situation. Then actually I have checked with the ANSYS reanalysis data. And for prediction and other concern, I have also collected the ECMW data, and that also been analyzed with this process. And for the case of meteorology, actually, I have tried to know how vulnerability of Bangladesh territory in respect to heat wave condition and number of hot days. Because in the recent year, what we found that the heat wave situation is not only concentrating in the pre-monsoon season, it is also appeared in the monsoon season, even in the after that monsoon seasons also. People are suffering very much, and they are having so many questions why these sort of things are coming after the season or earlier the seasons. So that's why we have to check with other relevant definitions, that the heat wave and the heat wave index. And I want to try to find out the synoptic forcings which are associated with heat wave. Then I have tried to compare 2 heat wave seasons, that is already I mentioned in 2014 and 2021. Is there any similarities there, or is there any teleconnections associated with that one? The teleconnection things I haven't put it here, but of course it will be in my paper. Then heat wave potential area, whether is there any variability or not in context of Bangladesh. So this way I have been trying. So let us see the maximum temperature from 1961 to 2020. You might have seen that from 2000 onward, the average maximum temperature above than 30.5 degrees Celsius, and it never come back to below its level of 30.5 degrees Celsius. That means maximum temperature is being increasing, and it has been becoming very much alarming in the recent years. And you might be knowing that in the recent, in 2018 and subsequently 2019, year was declared by WMO as the hottest year. That means southern and southeastern parts of Bangladesh, including Dhaka area, where the number of hot days are increasing, and it is significant not only at other places, even it is becoming significant in the Sylhet point also. So the number of hot days, let us see what it is behaving with the free monsoon season. And here you see this is the Rangpur, here it is being decreasing. It is the northern part of the northwestern region of Bangladesh. But in the case of Russia, you see there is it is being increasing slightly. But in the case of southwestern 2 station, it is seen, you have seen that it is being increasing significantly, and significant test has been showing that it is above the 95th percent of significant level. And in the case of Mymensingh, as I already told, it is located over the northern part of Bangladesh. Here it is being decreasing, but at other places it is being increasing. But in the case of Sylhet, you see, as I already told, it was not, that means the station was not recorded so much in the heat of days about or number of hot days even in pre-monsoon season. But interestingly, in 2014, you see the number of hot days was significant, and this year it overcome that one. But at other places, it was not so much overcome. It has, you see, in the case of Dhaka, it was lower than the, that means this year was the lower than the earlier year, earlier in 2014, but in other places it is being increasing. So this alarming information I want to explain like this is due to the applying the Mann-Kendall test, we have found that at Borishal and at Sylhet, it is highly significant. But in the case of Chattogram, which was not so much susceptible for hot wave days or heat days, whatever it is, and it was also becoming significant. Southwestern parts of Bangladesh is already being, it is showing the significant, but in the case of northwestern, northern part, it is not showing so much high. So for better understanding and for understanding the synoptic features, I have taken into consideration of both the seasons, both the years, in 2014 and 2021. In 2014, it was, you might have seen that there are the three significant heat wave situation. In the right panel, you might have, so these are the number of stations recorded heat waves. I have taken the heat wave situation, that means event has been selected in such a way that at least 10 number of stations, 10 number of nearby stations have been recording the temperature above than 36 degrees Celsius. And of course, as I already told you, 36 is the minimum threshold value of declaration of heat wave. But of course, it has some other interesting things that there. It has to be continued at least for 3 days, and it has to be wide coverage with the area of 10,000 square kilometers. So with this idea, actually, we have selected, you see, there are three events. And first event was for long, it was for 8 days, and second event was very long, it was for continued for 21 days, and the third event, it was also continuing for the 18 days. But this year, the heat wave situation becomes earlier than the earlier 2014. You see, this has been started from 21 March to 27 March, but duration was comparatively lower than the earlier years, though the number of events were higher this year. And these are the signature, which I want to show you that during that period, how the heat wave situation was varying over this territory, especially Indian territory as well as Bangladesh and adjoining area. So it has, you see, this is the maximum temperature of 29%. In the case of first event, it has extended up to even some part of the northeastern parts of Bangladesh, but it was very significant over the southwestern and western parts. In the case of second event in 21 April, you will see that it was also extended up to northeastern parts, and even it has good coverage over the southeastern parts of also Bangladesh, on Bangladesh. But in other cases, you see, it was very significant on 17th May. That means the temperature became much higher than normal temperature of that area, and it has overcome the 40 degrees Celsius also. And as this, and it has the duration for longer period, so people becoming very much unhappy with this sort of situation. So for understanding the synoptic features, actually I have not give you any showing. I haven't showing you any animation, but I have taken the particular dates within the period. You see, this is the case for 31 March synoptic features. Here there is a pressure trough which has been extended up to eastern part of Bangladesh across the West Bengal and adjoining area. And on that day, and it's nearby, you see there are the flow pattern, there are the anticyclonic flow over the Bay of Bengal. This anticyclonic flow, actually what I want to say right now after my analysis, it was the unusual phenomena, it was the rare phenomena during that period. This unusual phenomena, we are calling it blocking high. This blocking high was continued for longer period, and it has provided the loss of moisture to Bangladesh territory and adjoining area. And this has caused the high amount of moisture content over Bangladesh, as it has been detected as a relative humidity. And based on that one, I have tried to see that whether the atmosphere becomes sufficiently unstable or not. So this is the lifted index, special distribution of lifted index. You might have seen that lifted index was the much lower than the, that means there was the unstable atmosphere where the moisture content was high, and it has been extended over the Bangladesh region. In continuation with this, I haven't shown the figures, but I have tried with the analysis with different upward and downward solar and radiation or sensible heat and shortwave and longer radiation fluxes. I found that at point.
Dr. Manan, please limit your presentation.
Yeah. So I have checked with other phenomena. I found that there are the supportive features associated with this one. This one is the case for 2021. You might have seen that the signature was not sufficiently strong than the earlier one. That my point is the heat wave situation was much stronger in 2014 than 2021. So if we see the similar situation, found that in the case of 21 to 27 March, we found that there are strong westerly trough again extended up to southwestern parts of Bangladesh, and due to the blocking high over the Bay of Bengal, as it has been providing the lots of moisture and signature of relative humidity, of course, the atmosphere was becoming very much unstable. So let us have a computation of this, all of these things, whether the influence was sufficiently strong and where it was. So for that, actually, we have conducted some intensity analysis for that one with the recorded rainfall, recorded maximum temperature with the weighted sum. And with this weighted sum, we found that during the period of 2014, the heat wave condition was mainly concentrated over the southwestern and adjoining western parts of Bangladesh. And these are the three monsoon cases. These three are the individual cases. And in the case of 2014, it was a little bit different. It has not covered over the northwestern and northern parts of Bangladesh. Yes, I am finishing. And during the period also same situation is happening. So let us have a comparison between these two. That means in terms of index value, it was strong in 2014 and then in 2021. And again, it has been found that earlier one was mainly concentrated over the southwestern parts of Bangladesh, but in the recent one have the concentrated over the even it has good coverage over the eastern parts of Bangladesh. So with this analysis, I have few conclusions. Unusual heat wave is becoming common in Bangladesh. Heat wave affected area are being changing. New area of Bangladesh are under its threat. Synoptic forcings are responsible for the occurrence of heat wave. Then upward and downward heat flux is also playing some role that is responsible for this heat wave situation. Numerical analysis I haven't shown, but I found that it has the good indication and predictable in nature. That's why we have been able to monitor the heat wave situation in 2021 in a better way with the support of Bangladesh Red Crescent Society. Thank you, everybody. Thank you all.
Thank you. Thank you, Dr. Mandani. Professor Ajit sir, we have no time for questions.
Okay, but let's compliment Dr. Manan and his team for taking up this important aspect. Heat waves are becoming very cause of concern, and with the global warming and projected temperatures, these needs to be addressed, and his study positively is a welcome. So thank you so much. I understand that we are short of timings, so you can accordingly manage, please. Okay.
Thank you, sir. Thank you very much.
Welcome.
Sir, will you say something for the
I'll say, because I'm again apologize as I couldn't join the first presentation. Overall, I think the session had a wide ranging of presentations, the lightning, thunderstorms, WRF modeling, heat wave, and the methane, which constitute the severe weather phenomena, and also the cyclone was supposed to be presented. I am not sure whether it was presented or not. The quality of presentation was good. It does provide an opportunity for new research also to be taken up, because the severe weather is becoming a major cause for South Asia, and climate change projections indicate that frequency and severity of severe weather phenomena is going to increase. So as a meteorologist, researchers, as well as the operational community has to be ready for it. And the presentations here should be taken up for further refinement and